We'll be able to go over about 3 problems today. I was going to aim for number 5, number 7, and then I can't remember what number it is, but the one on the next page that wants second derivative. It says dx squared, no, d squared y over dx squared. And then hopefully we'll have, I don't know, 15, 20 minutes at the end so that you guys are able to try to get some questions answered and take care of little things. I definitely won't have a test outline for you tomorrow. I don't even have a test written yet. I'm still trying to correct your tests. So I got a busy weekend, unfortunately. But I feel like that's a fair trade-off. That I have a lot of stuff to do this weekend. No more what? No more calc? I'm confused what you're thinking. I meant trade-off as in, like, I was gone for a week, so, like, I'm okay doing a whole bunch of homework on the weekend. Not as in you won't have calc anymore this year. Correct. Yeah, the test will only be 3-1 to 3-3. Yeah, so today, the portion we finish today will be effectively the end of what you'll be tested on. So it will be chain rule from a table or graph, and then 3-3 implicit derivatives. It's basically only 2 topics, but they're not quick topics, so it's not like you're going to fly through this test, right? The test will have multiple choice on it because they need to start getting you prepped for that by the end of the year. I mean, the AP test has 45 multiple choice questions and 6 free response questions. So it's very imbalanced in terms of number of questions, but the point value is 50-50. So that's why they kind of make a big deal out of teaching free response, because they feel more difficult and they're weighted much heavier. But given that multiple choice is half your test, I want you to feel comfortable doing multiple choice too. Okay, question 5 looks relatively innocent. It is 100% not. The only portion of number 5 that makes it go badly is the angle being xy. When the angle is xy, they are being multiplied. So that's product. So our goal is to it just says differentiate, but better directions would say find dy dx. So we're not even plugging in a number, we're just finding the derivative. So I am going to take the derivative of this whole thing. Now, I can't remember in this class yesterday, did we just write y prime every time?
Yeah, there was one time you wrote.
Okay, I did write dy dx?
Yeah,
All right. Because I need you to be comfortable using either form. Depending on the problem you're given, I mean, this one doesn't say dy dx, so y prime would be absolutely acceptable. So I'll use y prime here, but I want to make sure to use both today since you're used to both. Okay, so let's do the right-hand side first because that's definitely easier. The right-hand side, derivative of x with respect to x. Like if I write it out, by the way, derivative of x with respect to the derivative of x is 1, because dx divided by dx is 1. That's why the derivative of x is 1. Like when you start using correct notation, sometimes things do feel clearer, but that's only once you're comfortable with correct notation. So derivative of x is 1. Derivative of 3y, 3 y prime. Are we okay with y prime? Okay. God dang it, I was going to point to this. Somebody erase it. So what you have to train yourself to do is over here, when we write ddx, we're specifically saying this is our independent variable, that's our focus. So every variable that is not x automatically has to have chain rule every time, and will have the variable prime at the end. Every term that has a different variable, you have to write that at the end of it. And it's gonna take a while to get used to that. Okay, so cosine xy. So the derivative of cosine of u is gonna be negative sine u times du, or u prime. Well, the derivative of xy is the product. So first, derivative of second, plus second, derivative of first. On its own, that isn't a big deal. Do you guys remember what we were trying to do after this, though? Like, this is considered the derivative, but your answer for the derivative generally has to be written as dy dx equals, or y prime equals. Like, at the end, it should say this. So why is this one horrible? Kind of. Try to think of this as one thing. I mean, it looks like a bunch, but that's just one thing. What makes this one horrible is that the y prime is inside the parentheses as well as outside. So we need to be able to combine y primes together, which means it can't be on the inside of the parentheses. So we have to get it out of the parentheses by distributing this to both terms. So it's not horrible, it's just gonna look horrible. I mean, like, there's no question about that. So negative sine xy times xy prime plus negative sine xy times y. And then that all equals the right hand side. All right, well, I now have, there's only 4 terms up here. One term plus a second term equals third plus fourth. 2 of the terms have a y prime, 2 do not. So our goal is to kind of move them to the correct sides. It doesn't matter which side you choose for what, but one side would have to have terms with y prime. One side would have to have terms that don't have y prime. Like that's our goal, to solve for y prime. Anybody have a preference? Yeah, yeah. Left side? Okay, sure. So that'll stay, that'll move, that'll stay, that'll move. So negative, I'm hoping you're okay with that and subtracting in your head, because I don't want to write that down. I wonder if they would write y in the front. Not sure. Okay. It looks far worse, but do you guys remember how we got y prime kind of on its own yesterday? Factored out. Because they both have y prime, if they're both multiplied by y prime, I think factored out. So y prime times negative sine xyx minus 3. I mean, the operations we're doing aren't like hard or complicated. I'm gonna guess that most of you this feels more complicated just because there's a lot written. I mean, like, once you get used to that, because this will happen often, it's not a bad problem, it just looks bad. Now I want to divide by the whole parentheses. So y prime is going to be, let me put the letter in the front just because it probably is considered more correct. That way you wouldn't confuse the y with the angle. The bottom will, oh, you know what? The bottom would be negative sine xyx minus 3. So I guarantee on a multiple choice answer, they would factor out that negative symbol and write it in the front of the fraction and write this as positive x sine xy plus 3. Multiple choice is always kind of weird like that. If you ever have minus and minus, like all the terms are negative, they usually factor that. You don't have to, but they usually do. So that would be our derivative, which this doesn't seem like it should be that horrible at the beginning. But there's definitely a lot more stuff than normal ones.
Where did you get like the X and Y from?
These two?
Yes.
They were, I originally had them written at the end. And I would bet a more correct way to write it would be in front so that you don't confuse with the angle. But this isn't wrong. You can read it that way. I guess I'm just trying to train you to look what answers would be on multiple choice. There absolutely is a lot of ways you can write this answer correctly, and that's fine with me. I don't know, how's that, was that a rough one to start with? Well, that's okay. You guys are smart, your brains are young, they're flexible. I doubt it. You most definitely cannot cancel the signs, if that's what you're asking. You can't because they're part of, the plus signs make it part of the other term. We could only cancel it if it was multiplied on the whole top, whole bottom. She was asking if this would cancel or not. The only time you can cancel is if you have something multiplied across the whole top, multiplied across the whole bottom, like if it was factored out type thing. The fact that there is a plus sign on both of those means that these are joined together unless you can factor it out. I know it looks like you should want to do it, but you definitely cannot. So no questions, or you just don't even know what to ask?
I did it, and I was like, I did it ahead of time, but I don't know if the way I did it is like equal to.
What'd you do?
I got negative sine xy squared minus
Nope.
1. Nice.
Now, I stopped you right there because I know what you did was you wrote the y at the end like I did,
Okay.
but you made it part of the angle.
Okay.
And the angle can't be altered.
Got it.
So your top would be correct if you didn't put the y on the inside and you wrote it up front.
Okay.
So yes, that would be equivalent otherwise. Having the negative on both of them is okay. That is the difficult part probably about checking the answer key too, huh? Like you're not always sure if yours is the same thing. Yeah. Should I move on? What, you guys, I absolutely killed you off. I guess I should have started with a much easier one. Yeah, always. If they don't get harder than this, then we would just basically be done with the class. Oh, this unit? No. No, this is probably up there. This one, the only reason it's difficult is because the sheer number of terms. The actual work we're doing isn't considered difficult. I used the chain rule when I did the angle, right there, and then I used the chain rule on the y. Yeah, that's where y prime comes from.
No, I just got a left side.
You definitely have to move your paper when you're asking the questions. Okay, what?
Like I get the left side, but the right side.
Like this side felt easy, but not that?
No, the. How do you use the chain?
Let's pretend it wasn't 3y. Let's pretend it was 3y to the fifth power. The derivative of 3y to the fifth power would be 15y to the fourth. And because it's a y and not an x, times dy dx, which is y prime. So that's the same thing I did here, except the difference is the derivative of 3y to the first, just 3.
Right.
But you still need that at the end. So that's technically considered chain rule because it's not x. We can do the chain rule on x every time if we want to. Derivative of x would be 1 times x prime. X prime is 1. I mean, like, it would seem overkill because we're doing the derivative of x multiple. Other letters.
Or the other.
Yeah, so what we're making our way towards is we're gonna have equations that are more than 2 variables. Let's think physics formulas. What's the physics formula again? Let's do like a volume one, like, there's gotta be a physics formula for volume of something. Huh?
1/2 acceleration times squared.
What's a regular physics formula? I can't think of it.
1/2 hg squared equals this.
Oh, that works. Force is mass times acceleration. Okay, that's a good one. They're all physics formulas. Okay, well, we would be taking the derivative of that. But there's no x's in there. What we would be doing is taking the derivative with respect to time. And then that would tell us how fast the force is changing compared to time. And we would have to do implicit derivatives because none of the variables are t. And that's what we're working our way towards. It's not any harder than this. You're probably more freaked out because it actually stands for something. But it's no different than this. That's what we're working our way towards. Okay, should we do 7 together? No, we definitely don't have time. Yeah, okay. I mean, we'll do it. I'm just telling you, we don't have time to do all of it. So given that crooked ellipse, find the equation of the tangent line at interval 2. Find the equation of the north. Oh, these are the same questions. Okay. Okay, but so x squared minus xy plus y squared equals 7. So we are absolutely starting off by taking the derivative of it because a tangent line needs slope and a point. We were told the point. We just need a slope. So derivative of x squared minus xy plus y squared equals 7. Derivative of x squared, 2x times x prime or dx dx. Minus product rule. Product rule of xy, make sure you put the minus in front of parentheses. That's going to be an easy mistake to forget. What do we have? X, y prime, plus y, x prime, plus derivative of y squared, 2y, y prime, equals 0. Anytime you do the derivative of not x, you have to put that at the end. If you're doing an x, you don't. I mean, it'll come once you keep practicing it.
Will you ever trick us and find like DDY and like change it? Like, will you ever
So,
trick us and make us so we find
ddx, if we think about this, slope, when you guys think about slope, you always think about how much it goes up and down compared to 1 square. Like a slope of 5 means you go up 5 over 1 square. So that's with respect to x because you only moved 1 square. If it asks you to find slope with respect to y, then what would happen is it's asking you how far it would go over if you go up 1 square. And I'm not going to trick you by doing that, but you will have to do derivative with respect to y on AP test. So we're not doing it right now. I think that's what you're asking. No, it'll say find DDY. I mean, like, it'll have some way of telling you what you're doing. Okay, I can solve this for y prime right now, or I can plug in -1, 2, and then solve for y prime afterwards. Order doesn't matter. Let's try plugging in the numbers, because we didn't do that yesterday. So let's plug in the numbers now and then solve for y prime as we go. So 2 times -1 minus -1 y prime plus 2 plus 2 times 2 times y prime. So I've got -2 plus 1y prime minus 2 plus 4y prime equals 0. -4, I would bring to the other side as 4. 1y prime plus 4y primes, 5y prime. That means the slope is 4/5. Should go. Should I pause and wait for you guys to catch up? Yeah, okay, that's problem, no problem. I plugged in the point -1, 2. So I put -1, 2 plus every x and y. And that's why y prime is still there. So you can do that at the very end or at the very beginning. It really doesn't matter what you do. I figured I would just show you both ways. If you're ever asked to find the slope at a point, you always have options as to when you want to plug that in. I don't care when you do it, I just figured I'd show you both ways. This is plugging in the number first and then solving for y prime. Yesterday, we solved for y prime and then plugged the number in.
If it was like DD, why would you put plug in 2?
If it was DDY, you would still plug in -1 in place of x, 2 in place of y. Your answer would stand for something else. If it was DDY, your answer would actually be 5/4, but that doesn't matter. You're not gonna be asked for that for y. Maybe I shouldn't have even answered the question. True. Okay. Oh, I forgot I was gonna call somebody. Fiona? So I've got a slope of 4/5. How do I write the tangent line?
Is it like y minus y something equals x?
I didn't hear that at all. I heard a fan.
Is it like y minus y1
Yep,
equals x or m times
Yep.
x minus x1?
yep. Correct. That's tangent line. If you wanted me to draw this to kind of show you, like, put it together, the point -1, 2 is right there. And that does look like pretty close to a slope of 1. So 4/5 is pretty close to 1. Normal line. Cody? Do you remember what a normal line is?
So that would be like, so it'd be, my mind's moving, sorry.
Perpendicular slope.
Okay, so it'd be negative, 504, and then it's times,
Everything else is the same.
say, x plus 1.
Yep, same point.
Yep.
The only thing that's gonna be different is the slope is -5/4. So tangent line would look like that. Well, that actually came out way better than I thought it would. Normal line would look like that. Part of the weird thing for your guys is you don't even know what we're using these for yet. It just takes so long to teach you how to figure out some of this stuff. That's what the other calc classes are for, and that's what the other, like, degree specific classes are for, teach you how to use this. Okay. Well, I kinda figured we'd only get 3 questions in today. This is the one I wanted to do last. Not the hardest at all, just different. John Woo? What does that mean? D squared y over dx squared. Perfect. Yep. That's what it's asking us to find. What? Yeah. It really screwed up my brain when you said it that way though. Double prime is usually the phrase that people use, but prime is correct. Anybody have any thoughts on which to start? Okay, let's take the first derivative. So we are going to do d dx once. By the way, I always thought this was super weird at first when the squared's in different spots, like it bothered me.
Yeah.
That's because d dx is the derivative, right? And so if you do d dx twice, d squared dx squared. That's where that comes from. Yeah. The letter in the upper right is just what you're working with. Okay, so d dx of cosine of y equals x. Looks fairly okay. Negative sine y times y prime. Actually, no, I have to write dy dx because it says it specifically in the problem. So let's get used to doing that. Well, the notation they used was d squared y dx squared. And if we write y prime, then it's equivalent, but it's not the same. It's annoying. It's a stupid rule. It's okay.
Would we get flex already?
On our test, no.
On the AP test?
Definitely.
Got it.
That's why I said it's a stupid rule, but I'm not the one that made the rules. I'm not also not the one that grades the rules. Yeah, that's pretty much why they grade it that way. I don't know. I would just not chance it. Okay, so I have to solve for dy dx still. Yeah, you just divide by negative sine y. But in fact, ooh, I don't know, should I do that? Yeah, we better. 1 divided by negative sine y, I should write as. Yeah. I know, I'm sorry. That's definitely, this is just much cleaner than 1 over sine. Come on, you write 1 over sine, that's. Your next problem is gonna be harder. Okay.
So we have done negative sine y, that's a negative 1, and then
Cosine y.
Yep.
times y prime.
Nope.
Minus sine
Well, I mean, like, it's easier for you, sure. It's not wrong. I'm doing this because I know this derivative is gonna be simpler than doing quotient rule of negative 1 over sine, or sine to the negative 1 would be like power rule with chain rule, which still works, so like you can do that. You're supposed to know all 6 derivatives. So. One over sine is cosine. Oh, you're talking about derivative?
Yeah.
Oh, gotcha. Oh, okay. See, d dx of d dx. D dx is just kind of like a verb saying I'm doing the derivative again. So I'm doing the derivative of the derivative that signifies that I'm of the second derivative. Okay, who should we go? Somebody's got to have these written down somewhere or memorized already.
Max knows.
All right, Max?
Go tangent. Go tangent.
I don't think so.
Oh, it's not.
What?
I thought it was like cosecant, cotan.
It's south times
Yeah.
What?
I thought it was cotangent.
Could be wrong, but off the top of my head, I believe the derivative of cosecant is negative cosecant cotan.
Maybe.
Yeah.
Yeah.
Cotangent is after it, yes, but you have to rewrite cosecant.
Oh,
Well,
okay.
technically,
It'd be a big difference on the test.
Oh, would be, okay.
Maybe you meant that to say, you know what, I don't know, I'll give you the benefit of the doubt. So, but because it's the negative, it would make it positive. Also, did somebody look this up yet? Because let's not go by my brain. My brain has had to memorize too many things over the years. Did you look it up? It was that? Perfect, thank you. Yeah, I was getting
you
it
write
right.
it as,
I wanted to make sure that was the correct derivative before I went with it.
shouldn't you write it as dy dx?
Oh, jeez, you're right. It won't matter in a second. Okay, so here's where I'm at with this one. And here's where I'm gonna tell you why this answer won't be right. I know, right? I don't know why, I mean, I guess I kinda know why. If I have to plug in some numbers now, like they say they give you a point to plug in. Well, we've got y's, I guess we don't really have any x's, that's fine. What would I plug in here if they give me a point? Nothing? No, that's definitely not true. Yes, you would either A, have to go back to this one and figure out dy dx from that point, or B, what you're supposed to do, like the official AP is supposed to do, but in reality it doesn't matter what you do, is they want this replaced with what you found. Yeah. That's the only reason I'm doing this problem with you guys, because that's the one part of the problem that will either not be done if I don't show it ahead of time, or not understood if you look at an answer key. So dy dx is negative cosecant y, so I now have two cosecants and a negative, so it is now cosecant squared. So that would be the second derivative. Yeah, it's not horrible, it's just, what traditionally happens is if a student goes and tries to do this question, the homework on their own ahead of time, almost guaranteed to come get asked the question, how did they go from here to here? Because in an answer key, they don't like highlight or essentially show this fact, they just write it in. And it's not always easily caught. So, higher order derivatives on implicit, well, yeah, implicit. Higher order derivatives on implicit, you're supposed to replace equations that you know the answer to. Okay. I'm done. That is where a derivative is.
Yeah.
Okay.
Yeah.
I know some of you may have questions from the sections 3.1 to 3.3. Obviously, tomorrow is me dedicating a full hour to answer questions. But I also know some people have questions that they, may look at or whatever.